Yes, go.
Okay. So we look at the modulator block diagram, and this is a BPSK modulator, right? BPSK, which is binary phase shift keying. In other words, there will be two phase changes. Okay, if you look at the constellation diagram, so whenever it's a 1, the phase is 0 of the carrier. Whenever it's a 0, the phase is 180. Okay, so there are two phases, okay, representing 1 and 0. Alright, let us look at the block diagram. So I have message which is 1s and 0s. It goes through a line encoder which changes its which will change it to pulses, and that will be my input to multiplier, and I need to multiply it with a carrier. So audio oscillator goes through a phase shifter, and then that goes as input, second input to your multiplier, and the output is a BPSK signal, right? Let us look at it. For example, I have bits 1 and 0. Okay, so M is 1 and 0. Line encoder will change it to square pulses, so it changes it to pulse, right? So a 1 is represented as +1 for the duration of the bit clock, and 0 is represented as -1 for the duration of the same bit clock, right? So this is my line encoder output, right? I have a carrier, and I need to always ensure this one. Okay, this is already ensured in the TIMS modules. The time period of the bit, or the bit clock time period, is actually 4 times of the carrier time period, right? And what it means that in each bit you will have 4 periods of carrier. So if you look at it, 1, 2, 3, 4. Same thing happens here. 1, 2, 3, 4. Okay? So in other words, TB should be an integer multiple of carrier, so that I have the whole time periods over here complete, right? Whenever it's a 1, the phase is 0, so it starts from 0, right? And 4 time periods. Whenever it's a 0, the phase is 180, so it starts from 0. It starts from the other side, inverted. Okay, and you can see that whenever there is a change in bits, the phase change is evident, right? It's either a W or it will be an M. Okay, we can draw one more here.
It was cosine and now sine.
It's a cosine. It's a sine.
Oh yeah.
Both of them are sine.
Oh, yeah,
it's
yeah.
always a sine. Okay. Let's put this blue. Okay, so I have a 1. So 1 is a 1 volt for the whole bit duration, right? If it's 1, the phase is 0, so that means the signal will start from here, and I will have 4 time periods, right? So 1, 2, 3, 4, right? You can see that whenever there is a change from 1 to 0, it's a W. Whenever there is a change from 0 to 1, it's a M. Alright, and this is my BPSK signal, right? I have a phase shifter here that will ensure that it's an M or a W, right? Okay, this phase shift, if it is not an M or a W, I will change the phase shifter to make it a good M or a W. Okay, we'll see it when we do the demo. Now, on the demodulation side, it is very similar to AM demodulation, AM with carrier, without carrier demodulation. Your BPSK signal is multiplied with the same carrier, and it should have the same phase as what it was in the transmitter, right? Multiply it, and then low pass filter. Okay, so when you pass it to a low pass filter, you should get your message here, right? Your message was, remember, pulses. But when you pass anything to a low pass filter, you will never get a pulse, because a pulse is summation of infinite harmonics, and some of the harmonics will be lost. So you will have distorted pulses. Okay? Then this output goes to a decision maker, which takes a decision whether, if I will take decision at points, okay, at same interval points, right? And when I take a decision over here, for example, I know that this is more than 0, so this should be a pulse like this. I will take a decision here, it is less than 0, so it's a pulse like this. I will take a decision here, it is more than 0, it's a pulse. Again, sorry, it is less than 0, so it's a 0. So now what happens after the decision maker, I get good shaped pulses, right? It's no more distorted, right?
Yeah.
And now this is my encoded output. I will pass it through a decoder, so he will change it to the bits that I wanted, right? So if it's something like this, it's a 1, 0, 1. So I'll get my output as 1, 0, 1.
101.
What I transmitted, 1, 0, 1. Okay? This is the whole modulation, demodulation. We'll make the connection now, okay? And what we'll do is, we'll make the whole connection using blue wires. Okay? Blue wires will be the whole connection in this same manner. Okay? And there will be yellow wires that will be used to see the output. Okay?
Okay.
Blue wires is for the whole connection, yellow wires is for
Output.
looking at the output. Alright, let's make the connection, okay?
No, you're wire.